Hi, welcome to Bald Spot Math. Today we're going to cover the basics of ratios, a very powerful concept in math that you will use or should be able to use your entire life. Here we go. First of all, the vocabulary. Ratio is a relationship comparing x units of one quantity to y units of another quantity. Of course, we don't usually say x units and y units. So what does that mean? It compares two quantities of something, numbers or of something. So maybe it's comparing the amount of dogs to cats, or the amount of desserts to dinners, or the amount of athletes to spectators. It is a way to compare two different quantities of something to itself and to the whole. And let's take a look at some examples. So I've got 16 action figures in my room. Actually, there's a lot more, but we're going to keep this simple. All right, I've got 12 male action figures and 4 female action figures. So I've got my numbers that I need to start making some ratios. And I can make lots of ratios. If I want to compare how many male action figures I have to the total amount of action figures, how many male action figures I have to the total action figures I have, I can use a ratio. And there's 3 ways to write a ratio. I can do it in words, 12 male to 16 total. I can do it with a colon in the middle, 12 male to 16 total. I can do it in fraction form, 12 male over 16 total. And I can completely get rid of the words as well, although very often having the words, especially for someone who doesn't know exactly what you're doing, is going to help them understand your meaning. So without labels, it's 12 with the word to 16, 12 with the colon, and again, it's still read as 12 to 16, and even in fraction form, it's read 12 to 16 when we're talking about ratios. So these are the 3 ways to write your ratios with or without descriptions. So there are 3 types of ratios, okay? The first is a part-to-part. So if I'm talking about my action figures, one part would be the male, one part would be the female group of action figures. So you get the 12 male figures to 4 female figures. Part of the overall group, part of the overall group, part to part. I can do a part to whole. So I've got 4 female figures to the 16 total. This is the part of the group, this is the whole group of action figures. I could have also done it with the male. I could have done 12 male figures to 16 total figures. Part to part to whole. I can also do whole to part. I can flip it and give you the whole part first and then the smaller part second. So I can do 16 total figures to 12 male figures. Those are the 3 kinds that you can do. Now, we talk about the fraction form of ratios. Ratios and fractions are extremely similar, but there are things that ratios can do that fractions can't. And you have to be careful about that. All right, ratios are not technically fractions. Some ratios can be written as fractions, and all ratios can be written in fraction form. So what can ratios do that fractions can't? Ratios are kind of like super fractions. All right? A ratio can have decimals. You can't have a decimal in the numerator and denominator and call it a fraction. But I can have decimals in my ratios. So I can have 3 2/10 minutes to 24 5/10 pizzas. If I turn this into a fraction, I'd have to get rid of the decimals. Ratios don't always have to be simplified. At least in my classroom, I always tell my students, simplify, 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 unless told otherwise. But with ratios, it may or may not be helpful or desirable to simplify a ratio. And that's it.